Continuous random variables can take on a lot of different forms. We see in the textbook for Chapter 5 in the introduction, you can have a uniform distribution, exponential, a normal or Gaussian distribution. There are other options too. I've seen some like triangles and different geometric shapes. The thing that's in common with all of these is the random variable x has the potential for infinite precision. In between 2 points, you could have an infinite number of values. So at a single point, the probability will be 0. I've put together an example of a uniform distribution here. So at a single point, we have just one sliver, one outcome out of an infinite number of possibilities. So on this uniform curve, we're saying that x can be anything from 0 to 8, and any decimal in between is possible, and each with equal probability. That's giving us that level, flat, uniform shape. And so what we'll have is the probability of being in a region will be determined by its area. And so you could see the full rectangle has an area of 1, a probability of x being from 0 to 8. We're shading in the whole box, that's 1. And then if I want to, let's see, if I want to look within a certain region, I would be looking at a fraction of that rectangle. So here's an example where the rectangle is 4 units wide, and then since the total area needs to be 1, it's a 1/4 or 1/4 height. So that way width times height equals 1 for the full box. But now our shaded area is some fraction of that. So here if we have a width of 2, that's 2 out of 4, or 2 times a quarter to get a 0.5, 50% probability. So you can see as that widens out, the height has to be reduced. That way we maintain that area of 1. And now if I have a width of 2 for a shaded region, out of 10 total, that's 3 minus 1 is 2, times a height of 0.1, or you could say divided by a potential 10, that's going to give me a probability of 2/10 or 20%. So you can kind of see how that works. Probability at a point is 0, but when we shade in, we're looking at what sort of fraction of the whole area is shaded.